So hello, my engineering students. Now in this particular video, what I have drawn here is a stress strain curve for a ductile material. Now, as I already explained to you in my earlier videos, that what is the difference between a ductile and what is the difference between a brittle material. So here I'm going to explain to you the stress strain curve. Now in this stress strain curve, what you can see here is the stress and strain relationship with respect to the elongation. Now we have the material here. You can see we have the ductile material. The ductile material is being elongated in the longitudinal direction through the ultimate tensile tester machine that holds the specimen and applies the force in opposite direction so that the necking formation takes place. Now here in the graph, the stress strain graph, I'll explain to you what is a proportionality limit, what is an elastic limit. There are two defined points, ultimate yield point upper and lower yield point, that is represented as D. Then you have the ultimate stress point. Here what you observe in a specimen is the ultimate tensile strength of a material and corresponding stress. You can note it down. This is your ultimate tensile stress and the corresponding strain is ultimate tensile strain. Now students, very important is to understand the phenomenon, how the phenomenon of elastic and plastic deformation takes place. Now elastic and plastic deformation, so this is basically a deformation phenomenon. Whenever the specimen is elongated, there is a proportionality limit, and we also say this is your Hooke's law. Hooke's law states that your stress is directly proportional to your strain and you are obtaining a complete linear graph. All right. Then from A to point B, there is an elastic limit, means at this limit, if you remove the force, then automatically the molecules of the specimen will come back to its original shape. From B to C, you will experience the yield at which there will be a plastic deformation being taken place. So there are two trends being formed. One is your upper elastic limit and another is your lower elastic limit. Now, after we apply the strain from the lower yield point to the point E, there is a maximum stress that has been developed inside the specimen. So this is known as your ultimate tensile strength. Ultimate tensile strength. And after you apply the force, there will be the breaking point, that is the fracture takes place. Fracture takes place and the material is being broken down, and this specimen, you can see there will be the necking formation and there will be the breaking of the specimen. So here the very important phenomenon in the stress strain curve is the formation of the curve along the x, that is your strain, and the y, that is your stress axis. So x and y axis, they are basically representing the stress and the strain, and the proportionality limits, the elastic limits, the yield points, these are very, very important phenomenon in the stress strain curve relationship. So thank you students.